Okay, so let's go through this moles equation. We're going to use the method DMESMA, diagram moles equation, sample moles answer. So the first thing we need to do is draw a diagram. So we're going to go through the question and pull out all of the data from it. Your diagram's always going to look the same. You're going to have a conical flask with a burette. Maybe you'll have a volumetric flask before if there's a sample. So let's go through it then. So we prepare a 100 centimetre cube solution, and that is 3.215 grams, and that is of chemical D. They then titrate 25 centimetre cube samples. So the 25 centimetre cubed is what is going to be in your conical flask, because you'll use a 25 centimetre cubed volumetric pipette to put it in there. And let's keep track, that's D. And what are we titrating that with? Some barium hydroxide. I'm just reading through the question here one bit at a time, and the concentration of that is 0.15 moles per decimeter cubed, and it says the tetra down here is 23.5 centimeters cubed. Okay, we've done our diagram, the most important step, because it lets us see what's going on. So straight away I can tell what we've got here is a sample. We've got a larger volume and we've tipped out a smaller volume. So straight away let's calculate our sample factor. The sample factor is, let me write up here, it's big V over small v. So in this case that'll be 100 divided by 25, or 4. So I've done my diagram, and if there's a sample, you may as well calculate the sample factor. That tells me there's 4 times more moles in the big thing than there is in the small thing. So a diagram. Next step, let's find the moles. It doesn't matter what, it doesn't matter how, just find the moles of something. So it's going to be the barium hydroxide, isn't it? And let's keep track of where we are. At the moment, we're in the burette with the barium hydroxide. So my moles of barium hydroxide is going to be equal to CV. So 0.15 times 0.0235, because of course this needs to be in decimeters cubed, and that'll give you this answer here. Next, we're going to use the balanced equation to convert the moles of the thing you've just found out into the moles of what the question's asking about, which in this case is D, and it tells us that 1 mole of barium hydroxide reacts with 2 moles of D. So it gives you that molar ratio. So moles of D is 2 times the moles of barium hydroxide, which will equal 7.05 times 10 to the minus 3. That takes us from the burette to the conical flask, because these molar ratios only tell you what's reacted, and what did the burette get titrated into? The conical flask. But we don't care about that, we care about the number of moles in the original solution. So that's where the sample comes in. We're just going to multiply by the sample factor, which we already found out earlier was 4. So this was my moles of D in 25 centimetres. Now we're going to find our moles of D in 100 centimetres. So 4 times our previous answer, which will equal 0.0282. Whereas this first moles equation always starts moles equals, this second moles equation always starts with whatever the question is asking. So in this case, we're asked to find the identity, and so we're going to need MR. So it's going to be MR of D equals mass over moles. We know the mass from the question, and it's dead obvious. Look how easy the diagram makes it. You've got all the numbers at your fingertips, a massive help. So that's going to be 3.215 over our moles that we just found out, and that will give you 114. So on the previous page it gave you the general formula, CnH2n-1 COOH. So the formula that fits 114 is C5H9 COOH.